let's solve the problem of binary search tree iterator. We want to write an iterator for a binary search tree. And when we call the hasNext, while iterator hasNext and print out the next element, we should print out the in-order traversal of the binary search tree elements. The constructor needs to pass in the root. Then we should be able to call the hasNext and next in the time complexity of 1. And the space have a constraint OH. H is the height of the tree. So if we convert this binary search tree into a array or array list, then use the array list's iterator. It won't work because the actual space for this array list or array will exceed the OH memory constraint. So we have to do the iteration in place. We already solved a different problem in order traversal BSD iteratively. And if we look at that problem, it's very similar. You see, in order traversal binary search tree iteratively, we first go from the root to the leftmost node. Here, we put all the elements on the path into a stack. And then we pop the elements out of the stack, and at this place, this is our next value should be. And once we know the next value, we need to take care of the right node. We need to add the right node, and or it's we add the right node, and we also go to the leftmost node on of the left branch until we reach the leftmost node, and we add them into the stack. So next time when we ask for the next element, this one will be the next element. Then we trace back at give this element, then give this element. Once we have this element, we need to travel to the right node in order to prepare for the next element. So you see, this way, when you iterate through the tree node, we can give the next element in amortized 1 performance. And since we didn't use actual space to store those nodes, we only have a stack. The stack at maximum, the stack's maximum size is no bigger than the tree height. So this data structure satisfies our requirement. And as you see, a little bit of modification should work. We implement the iterator. We pass in the root as a constructor. We push all the nodes. We push all the nodes into the stack. When we call hasNext, we just need to make sure the stack is not empty. When we call next, the element at the top of the stack is our next element. But before we return the result, we need to check the right node and add all those necessary nodes into the stack. So next time when we call the stack pop, it is already, the next element is already in place. So just by iterate through the tree nodes iteratively, we can create a iterator implementation for binary search tree. This is quite a fundamental problem, how to iterate through a binary search tree. And in this case, the in-order traversal only costs 1. That's why we use this is a basic of a tree map. We can get the ordered collection instead of random collection, like hash map. So let's remember this iterator implementation for binary search tree.